Welcome to my video course on mastering ERTMS ETCS signaling systems. Today, we're unpacking the massive task force assembled to build a unified European railway network. To really grasp how this interoperable system actually functions, we've got to look way beyond just the hardware and the software. We have to understand the people, the organizations, and the specific roles they all play. It's essentially a masterclass in international coordination, where governing bodies, fiercely competing suppliers, and national operators all have to align perfectly. Let's get right into it. Here is our roadmap for today. First, we'll tackle the interoperability challenge. Then, we look at the ERA steering the standards, followed by UNISIG and the suppliers. After that, we'll cover the infrastructure managers, and finally, the railway undertakings. All right, part 1, the Interoperability Challenge. So picture this. Back in 1989, the European Union was staring down a massive historical hurdle. We're talking about roughly 30 completely different, completely incompatible legacy signaling systems scattered across the continent. I mean, imagine driving your car across Europe, right? But at every single border, you have to literally rip out your dashboard and steering wheel because the traffic laws and signs have totally changed. That was the actual reality for trains. Locomotives either had to be physically swapped at borders, or you had to pack the driver's cabins with a dozen different crazy expensive screens and computers just to read all the various national signals. So the vision for a single, unified European train control system, or ETCS, was born to replace those legacy trackside signals with standardized in-cabin displays, a real game changer. Moving on to part 2, the ERA, and how they steer the standards. Now, to fix all that fragmentation we just talked about, a top-level governing body was absolutely essential. I mean, you can't just tell 30 different countries to play nice and work together without a central authority to, manage the disputes, set the safety standards, and handle the inevitable software updates. That's exactly where the European Railway Agency, or ERA, steps in. They act as the ultimate manager. They make sure that every software baseline and every complex system requirement aligns perfectly across the entire continent. Whenever a new version or a baseline of the system specs drops, the ERA governs that whole modification process. They're the ones ensuring safety is never compromised, and that when a train crosses from, say, Germany into France, that digital handshake between the track and the train is strictly regulated and standardized. Which brings us to Section 3, UNISIG and the suppliers. So, the ERA sets the rules, right? But someone actually has to get their hands dirty, write the highly technical code, and build the physical components. Enter UNISIG. Formed back in 1998, this consortium took on the absolutely monumental task of slicing this interoperable platform into functional subsystems. And this group was crucial because it basically forced the industry's fiercest competitors to sit down at the exact same table and agree on exactly how a train should electronically talk to a track. And these are the heavy hitters. We're talking about suppliers like Alcatel, Alstom, Ansaldo Signal, Bombardier, Invensys Rail, Siemens, and Thales. These companies are literally the giants of railway engineering. By forming UNISIG, they agreed to develop common system requirement specifications over the decades so their systems could actually interoperate. Now, this was a massive paradigm shift. Historically, a company would build a proprietary system specifically to lock a country into buying only their equipment for decades. But ERTMS forced them to build standardized interfaces instead. Pretty huge deal. But as you might guess, it wasn't all smooth sailing. There was a major point of friction early on. You see, the original ETCS specifications were written in natural language prose, basically just dense engineering documents. Because of this, different engineers at different companies interpreted the words, differently. It's the classic human factor. So even though everyone was supposedly reading the exact same rulebook, the software they actually wrote ended up behaving slightly differently. This divergence meant that true interoperability wasn't achieved right out of the gate, and it really highlighted exactly why rigorous formal standardizations and open proof methodologies became so desperately needed in the later phases of the project. All right, let's look at Section 4, Infrastructure Managers. With the rules fully written out, we shift gears to the organizations that own the dirt, the steel rails, and everything attached to them, the infrastructure managers. These guys are the backbone of the entire system. Their job is to replace those old-school conventional optical signals with advanced trackside technology to guarantee safe train separation. Back in the day, they just maintained colored lights on poles beside the track. But in the ERTMS era, their job is entirely digital and wireless. They literally have to guarantee that the data being beamed to a train, which might be traveling at hundreds of kilometers per hour, is absolutely flawless. Just to give you a sense of scale here, a single radio block center, or RBC, acts as the safe central brain managing all train traffic within a radius of up to 70 kilometers. That is massive. Meanwhile, down on the sleepers between the rails, these infrastructure managers are installing Eurobalises. Think of them as track magnets acting like digital milestones, giving passing trains their exact pinpoint location. And since all this movement authority is being sent wirelessly, they also have to manage the key management systems. This involves generating and constantly updating cryptographic keys to ensure that all this critical data cannot be hacked or tampered with.
And that leads us to our final group in Section 5, Railway Undertakings.
If the infrastructure managers own the roads, you can think of the railway undertakings as the folks who own the cars. These are your operators, and they are heavily invested in this because they're the ones bearing the extremely high lifecycle costs of software upgrades, and they absolutely rely on strict standardization to cross borders seamlessly. We're talking about groups with massive fleets like Deutsche Bahn in Germany, FS in Italy, and SNCF in France. Equipping just a single train with these complex ETCS computers costs a fortune, so they need this whole ecosystem to work flawlessly. The last thing they want is for a train they upgrade today to get grounded by some software incompatibility at a border crossing tomorrow. So what's actually happening inside the locomotive? Well, the European Vital Computer, or EVC, acts as the onboard brain. It's constantly calculating braking curves based on the data it's getting from the track. The driver interacts with all of this through the driver-machine interface, or DMI. It's a highly standardized monitor showing their instantaneous speed, their permitted movement authority, and any upcoming track conditions. The railway undertakings are also in charge of the strict protocols their drivers have to follow. For example, the start of mission procedure. This ensures the train safely connects to the network, double-checks its exact position, and gets explicit permission to move before it even rolls a single inch. When you lay it all out side by side like this, you can really see how one half of the system simply cannot exist without the other. The radio block center track side, totally useless if the vital computer on board doesn't understand its messages. The Eurobalise down on the ground, pointless if the onboard unit doesn't have an antenna to read it. It is a continuous, perfect digital dialogue between the stationary trackside infrastructure managers and the highly dynamic, train-borne environment of the railway undertakings. Ultimately, a fully interoperable railway is only possible when this entire ecosystem collaborates perfectly. The ERA sets the standard, UNISIG builds to it, infrastructure managers lay the network, and railway undertakings drive the trains. It's truly a masterclass in international cooperation. But as these digital systems grow ever more complex and interconnected, it leaves us with a pretty critical question for the future. As we completely digitize our international borders, how will we protect this massive, unified network from the cybersecurity threats of tomorrow? Thanks, we can see you next video.